Hello, calculus students. I hope you are doing well. So in this video or a series of videos, I am going to go over your checklist and the practice final. Try to provide you with a step-by-step solutions, and I hope you will take advantage of this resource, and I hope you will do well. All right, so let's take a look first at what I'm talking about, the checklist and the practice final exam. All right, so this is what I'm talking about. And obviously you have discovered this document in your Canvas, checklist and practice for the final exam. So first I have a sort of an outline of what kind of problems, what format of problems you can expect. And then I have topics for review from, it's a comprehensive final, as you know. So it's a list of the things that I would be asking about. Okay, whether it's in the multiple choice questions or in free response questions. You do want to review these them rather quickly. And then, so there are 20. On page 2, you see I have notes here telling you what you do not have to study or to be, you don't have to be responsible for these things. Curvature, Lagrange multipliers, mass moments, inertias, Jacobians, and these kind of topics are not the big highlights of Calculus 3, and therefore I have decided that I will not include these topics on your final. And then the last thing, horrible, ugly calculations. If you happen to work on these problems on the final, and in the middle of your final, you find yourself working with terribly messy, very ugly, horrendous equations, that's probably because you have made a mistake. So you may want to go over. I try to make calculations simple because I want to test you over your knowledge and skills you learn in Calculus 3 and not on messy calculations. All right, so that's the first two pages. And those pages are followed by 2 pages of practical questions that you may see, and mostly from chapter 6, since there was no separate exam for chapter 6. And I think I have 19 questions here, and I will go over these problems much more carefully than the first 20 topics from the comprehensive review section, which I have called the checklist for the final. All right, so that's what I plan to do. All right, now let me share the solution, the answer key for the first part. Okay. Okay, so as for the checklist, I want you to just look at the what I have in red. All right, what I have entered in red. So number 1, for instance, what do you know about the dot product and the cross product? Okay, how are they related to the angle between those two vectors? And so this is really what you have to know. So go over these, make sure that these things do make sense. Similar for number 2. What do you know about the dot product and the cross product when the vectors are parallel to each other, perpendicular or orthogonal to each other? You may want to pay close attention to just this line. In mathematics, the orthogonality, the word orthogonal, is defined in terms of the dot product, or more generally, an inner product given for the space. And so, if somebody asks you, what does an orthogonal vectors, what do orthogonal vectors mean? Or the word orthogonal. What you want to say is that the dot product or the inner product is 0, as opposed to referring to the angle between two vectors, because there may not be visible or a specific angle between any two vectors when we talk about more general setting. Okay, so that's the mathematical, formal, precise definition of orthogonality, that the inner product or the dot product is 0. Okay, so you can talk about, if what happens, what do you know about the angle when the dot product between two vectors is 0, positive, or negative? So that's part C of number 2. All right, again, make sure you review the answers that I have provided here in red. Number 3 have to do with the projection. Number 4 has to do with quadric surfaces, and these are, of course, ellipses, ellipsoids, paraboloids, hyperboloids, and so on. Okay, make sure you know how to draw traces, and they will help you. Those traces will help you draw a sort of a 3D sketch of the quadric surface. And then number 5 has to do with the directional derivative. Number 6 has to do with the gradient. Many people, many students in the past have mixed up 5 and 6. So for instance, people would say something like the directional derivative always points to the direction of the maximum increase. Okay. You know that's wrong because the directional derivative, as the term suggests, depends on the direction, right? The directional derivative at a given point depends on the direction given by this unit vector u. And by the way, if this vector that shows the direction is not a unit vector, the first thing you have to do is to normalize it to make the length equal to 1, right? Number 6, the magnitude and the direction of the gradient. Now, remember the gradient at each point is fixed, right? It's a fixed arrow or the fixed vector whose direction means the direction of the maximum increase or the maximum rate of change. And the magnitude is that maximum rate of change among among the derivatives in all sorts of directions, right? So make sure you understand 5 and 6 and distinguish these two. Right? And then 7, it's a straightforward questions about parametric equations of a line in 3-dimensional space. Number 8 is one for a plane. These are very fundamental concepts that you learned in the first chapter, so I hope you still remember them. And then number 9, you are to write an equation of the plane tangent to a given surface, and the surface is given by z equals this multivariable function, right? If z is given as a function of x and y, then there is a very standard way of doing this, and that is to find the partials, fx and fy, and then the last component will be -1. And just because z is on the opposite side, and if you remember how this was developed in the class, you would see why that last one is -1. Okay. You can also think of this as the surface as the contour surface for f minus z equal to 0. See, if z is equal to f, then of course f of xy must be equal to z, right? So f of xy minus z is equal to 0 is the equation of the surface. And then you take the gradient, and that's going to be fx, fy, and then -1, because the equation that you will start with is f of xy minus z is equal to 0. Anyway, just know this because this is a something that you have used frequently, right? All right, number 10, again, the standard questions about velocity, speed, acceleration, and so on. And then how do you find the arc length of a given parametrized curve is part B of number 10. In number 11, and I may have questions like this where I do not, or I may not give you specific functions, but I may just ask you to state in your own words, how do you do such and such? Okay, so for instance, how do you find the local maxima and minima and saddle points when you are given a function of x and y? That's 11a. And how about absolute maximum and minimum? And these are quite different. Yes, both require you to first find critical points and so on, but there's a lot more to do when you are asked to find an absolute maximum and an absolute minimum in a closed and bounded interval or closed and bounded region, right? And so make sure you do know these things. In particular, for the absolute extrema, you would have to check the edges or the boundary of the region R, right? You restrict the function to the boundary and figure out if there are any possible maximum or minimum points on the boundary. Those are called critical points on the boundary, right? And check the corners if the region happens to be a polygon. Number 12, make sure you know how the 3 coordinate systems are related to each other. And of course, I mean the Euclidean, cylindrical, and the spherical coordinate systems. Number 13, how do you interpret an equation written in cylindrical or spherical coordinates, right? So you should know, for instance, the equation of a sphere in the spherical coordinate system. That should be pretty simple, as long as the sphere is centered at the origin, and so on. Okay, so again, review the what's written here. Number 14, double and triple integrals. How do you switch the order of integration? I am pretty certain you will have a question where you would have to switch the order of integration, from dy dx to dx dy or vice versa. Number 15 has to do with the lower and upper limits of integration. This is a difficult question. You had many questions in chapter 5 about this setup. And so you may want to review a couple of questions from chapter 5 on multiple integration. And then number 16, this goes into chapter 6. How do you identify and sketch the surfaces if a surface is given by parameters u and v, right? And then how do you find the surface area and that kind of questions? Okay, again, this is from chapter 16. Chapter 6, I'm sorry. And then number 17 has to do with the fundamental theorem of line integrals and the conservative vector fields and their corresponding potential functions. So make sure you remember what those words mean. Number 18, the fundamental theorem of line integrals is similar to the fundamental theorem of calculus that you learned in Calculus 1. Compare and contrast those two fundamental theorems. Okay, one is of higher dimensional than the other. And then number 19, what does Stokes' theorem say? And it is similar to Green's theorem, right? You just let Green's theorem fly in the air and you get Stokes' theorem. What does that mean? Okay, you may want to review that. And then number 20, it's a list of integrals that you are to make sure to know, right? And then why isn't there a work integral along the surface? And there is a clear-cut answer here. Okay, again, notes here, the things that you do not have to remember, those things are listed here. All right, so that's the checklist, okay? And so you will go over those, I'm sure. And then for the next 19 questions on some practice final, I will be going over them more carefully. All right, so let's go to the next part of this video.